Hello and welcome back to Machine Learning. I'm Jivita Christie, and in this video, we are going to continue to talk about feature subset selection from the previous video. And we will basically see the whole process through a diagram and understand how it is actually implemented. So let's begin. This is what the feature selection process looks like. You first have the full feature set from which you will generate a subset. Then you will evaluate if that subset is good or not. Okay. There will be a stopping criterion which will tell you at what point you can say that the subset is good, or at what point you can say the subset is not good. So if it's not good, you go back and generate another subset and check it. If it is good, then you can stop and just validate your result. Just see whether that subset works or not. So that is the overall feature subset selection process. Let's take a look at all the steps one by one. So in subset generation, which is our first step, you just have to have a search procedure which should produce all the possible candidate subsets. So this is like just generating all the possible subsets of one given set. So we know that if you have an n-dimensional data set, you can have 2 raised to n different subsets, right? Which is a very big number. So if n becomes high, then calculating this becomes intractable, right? You cannot generate so many subsets. So for that reason, there are a lot of approximate strategies which are employed to find these subsets for evaluation. Okay. And on the one hand, the search may start with an empty set. So there are several strategies. The first kind of strategy is that you start with an empty set and then keep on adding features. So that means initially you have an empty set, you don't have to do anything, but later you add one feature to it and check if that one feature is evaluated, whether it is helpful or not. Okay. And so this is known as a sequential forward selection. So you go on adding one feature at a time and checking if that subset works or not. The other possibility is to start with a full set and then evaluating it and then successively removing features. So then if you have 10 features, you start with 10 features, but then remove one and check whether that works or not. Remove another one and check if that works or not. And eventually you'll end up with the correct set of features. So this is known as sequential backward elimination. And in certain cases, search starts with both ends. So you would be adding and removing features simultaneously. So this strategy is known as bidirectional selection because it's both the ends. And each candidate subset, once you have your subset, you're going to evaluate it and compare it with the best performing subset. So this is like finding the max number out of all the numbers. You're just going to first start by saying that the first number is maximum, then check the second one, and if you find that's greater, make that maximum, and so on till you've actually found your maximum number, or till you've checked all the numbers in your list. So this is the same thing. Every subset that performs better than the previous one is considered the best for now, and you will check all the subsets. In the end, you will have the best one. So if the new subset performs better, you just replace the previous one, and this cycle is going to continue till the stopping criterion is fulfilled. And some of the commonly used stopping criteria. So what is stopping criteria? It basically tells you when to stop this selection process or feature subset generation process. So how do you do that? You could stop when the search completes. That means you could stop when you have evaluated each and every subset through forward or backward selection. Or you could have some given bound, like number of iterations, that maybe you just want to have 15 trials and then you want to stop. So that could be a stopping criterion. You could also have subsequent addition or deletion of the feature if that is not producing any better subset. Okay, that means you went on adding or deleting some feature and you did that for a couple of iterations, and you found that that is not resulting into a good subset, not resulting into a better subset than the previous one. You could stop at that point as well. Or if you got a sufficiently good subset, okay, which means you're getting good accuracy with that subset and everything, than the existing benchmark, then also you could stop. Okay, so once you have selected your best subset, you are going to validate it against prior benchmarks, okay, or by experiments using real life or synthetic but authentic data sets. And if you are using a supervised learning algorithm, then you can check the accuracy of your model to see if your subset is good or not. Accuracy of the model is compared against accuracy of the model that was generated by some other subset. And you can see if accuracy is high enough, then that subset is working. If you have unsupervised algorithm, then like clustering, then you could check the cluster quality. Okay, is the cluster quality good or not? How would you validate that? So if that quality is good, then your subset is working. Now let's talk about different feature selection approaches. So there are 4 kinds mainly. The first one is filter approach, the wrapper approach, the hybrid approach, and the embedded approach. Let's see what all those are. The first one is filter approach. In the filter approach, the feature subset is selected based on statistical measures done to assess the merits of the features from the data perspective. Okay, so here you do not have any learning algorithm to evaluate the goodness of feature, but there are some common statistical tests, and those tests are given here. Some names are given here, like Pearson's correlation, information gain, Fisher score, analysis of variance, which is known as ANOVA, or chi-square. All these things are there, so you could check that. And here is a small diagram showing you what the filter approach looks like in practice. So you begin with a full feature set, you select the best subset from there, and that then you check your apply to a learning algorithm and see the performance. So basically, you are not checking the performance of all the subsets. You are just applying some statistical measures to select a subset, and then just using it. So you're not comparing it with others. You're just going to start using it. Okay. The next approach is the wrapper approach. Identification of best feature here is done using the induction algorithm as a black box. So it searches for a good feature subset using the induction algorithm itself as a part of the evaluation function. So for every candidate subset, the learning model is trained, and then the result is evaluated by running the algorithm itself. So it's obviously computationally very expensive, because if you have a really huge data set and you're going to go on, selecting subsets of features and then applying the algorithm on those to calculate accuracy or some measure, then it's going to be very expensive, time consuming as well. Okay, but the performance is going to be generally superior to filter approach, because in filter approach, you're not testing the subset, you're just selecting the subset and using it. And you're only using statistical measures, whereas here you're using machine learning to actually check if the subset is good or not. So this is a diagram showing you what wrapper approach looks like. So here you begin with a full feature set, and then you're going to perform all this. You will generate a subset, okay, and check and apply your algorithm, machine learning algorithm on it, and then you can check its performance. So performance can be like accuracy or precision or whatever evaluation measures we have seen. So check that. then generate another subset, again run the algorithm and check the performance, and this process continues till you have maybe exhausted all the subsets, and then you see which subset is having the highest performance and use that one for your model. The next approach is the hybrid approach, which takes the advantage of both the filter method as well as the wrapper approach. So what happens here, it makes use of both the statistical tests as used in filter approach to decide the best subsets for a given cardinality, and a learning algorithm to select the final best subset among the best subsets across different cardinalities. Okay, so the hybrid approach is nothing but a combination of statistics as well as a combination of filter as well as wrapper approach. So what you will do is you will use statistics to select some subsets, and then for those subsets you will apply the algorithm to see which of those are the best, is the best. Okay, so that is the hybrid approach. The next approach is the embedded approach, which is quite similar to the wrapper approach because it also uses the inductive algorithm to evaluate the generated feature subsets. But the difference is that it performs feature selection and classification simultaneously. So it's not just feature selection, but also classification. And this is what it looks like in a diagram. You begin with a full feature set, generate a subset, check with the learning algorithm, check the performance as well. Again, generate another one, check the performance. So you see that both the things are being done together here instead of separately as it was done in the wrapper approach. So these are the different approaches and the overall feature subset selection process. And now we're going to try and implement some of this, some of what we have learned about feature subset selection. So let's do that. Now for feature subset selection, we saw some of the methods, right? We saw mutual information and stuff like that. So you could use those methods, but at the same time, you could use whatever is available in Python directly. Okay, we saw that there can be some statistical measures used to select features in feature subset selection. So you could use those as well. Okay, now let's talk about statistical measures, because the other kinds of measures are simply, taking features and decide, picking some of the features and then checking the performance of an algorithm, which is fairly simple for you because you have done so many programs on machine learning algorithms. So you could just go back there and try to take a subset of the features and see if that improves your accuracy or not. And you could just repeat that process, repeat that experiment to check it. So I'm not going to show you how you can use machine learning to do feature subset selection. I'm just going to show you how you can do it statistically. So statistically, there are many measures. I'm going to show you which measures are there, but the one that I'm using here is the chi-square measure. Chi-square is simply a probability distribution that can be used to generate, some numbers related to these features, which can tell you which of the features is better than the other. So these are the libraries we require for that. We have import pandas, numpy, and from feature selection, we will get select k-best and also pi2. Okay, so this is our a sort of CSV file that we are using. We are printing out the first 5 rows. This is also a file that we have used before. So this data set is not unfamiliar. It just has 7 attributes. We don't know the names of those attributes, but there are 7 attributes with some values. And the class variable contains classes like 1 and 0. So it's a very good classification data set. We will divide this into predictors and target. So target is, of course, this class variable with index 7. And predictors are everything from 0 to 6. So 0, 1, 2, 3, 4, 5, and 6. And we are going to write 0 to 7 because we want 6 to be included. Okay. Now, how do we do the feature subset selection? So you just basically have to write test equal to select k best and pass into it pi2 and k equal to 2. Okay, so we want to select the k best features, and we want to do that using chi-square. And we are going to, to do this testing, we are going to fit the predictors and the target columns right here. Okay. Next, we are going to transform the predictors into features, and then we are going to print everything. So what columns are present in the predictors? If you just print all that, you will get these columns because those are the columns present in our predictor variable. Okay. Now we are going to see with precision 3 what are the fitness scores of all these features. So these are calculated using the chi-square. So basically from these scores, you can decide which of the features you want to use and which you don't want to use. And you can, so this is a statistical measure. And just like chi-square, you have other statistical measures. Like if you want to use ANOVA, you could use that. Instead of pi, you can write f underscore classif. You can use mutual information, F regression, mutual information for a continuous variable, percentile, FPR, false positive rate, right? So some of these you might have seen before, some of these you may not understand now, which is fine, but I'm just showing you the different options that are available for you to explore as far as feature subset selection goes. Okay. You obviously have the other method where you can do forward or backward selection and then test it out by running your machine learning algorithm and see which one gives you the best accuracy or precision or any other evaluation parameter. So I hope you understood all this, and that's it for this video. Thank you for watching.